Okay, number 1 I said. Thanks.
Number what?
Yeah, number 1.
On the warm-up. Oh, on the board. I got 4, but I don't know if
Anytime we have two negatives next to each other, they make a... So our answer is what, Caitlin?
10.
Thank you. Our answer is 10. Please focus in here. Number 2. What are these bars right here, Camden Zeller? Those are absolute value. Absolute value makes everything
positive.
So our answer is 8. Nice job. Number 3. Solving equations here. Anytime we solve equations, we want to isolate the variable. Okay, what's the first step going to be, Bryce?
Subtract or add 11.
I'd subtract 2x first. You could add 11.
Keep it. Try and keep it.
So you get 3 equals 7x minus 11. Why remove the 2x, Camden? You made a great point.
Keep it positive.
Yeah, we want to keep the variable positive. So from there, then I add 11 to the other side. And I'm going to get an answer of what, Trevor?
X equals 2.
X equals 2. Nice job. Number 4. Might be a trick question for you. Troy, what'd you do first? Subtract 3x. I like it. That's what I do. Keep the variable positive. But you have to remember what's going to be on that left side now, Troy. 0. You get 0 equals x minus 5. Now you might be able to think what minus 5 is 0, and you get the answer. If not, you add 5 to the other side, and you can still get the same answer because our answer is what, Troy? X equals 5. Very good, sir.
Wait.
Yes, sir.
If you did it by subtracting the 4, you still get the same.
You divide by -1, you get the same answer. Yes, sir.
Okay.
And number 5, find the mean. Jersey, what's the mean again? The mean is the average. Add them all up, divide by 7. I get an answer of what, Jersey?
4.
Jersey?
4.
Thank you, sir. We do get an answer of 4. Segments. Measuring and constructing segments. Section 1.2. We are in geometry. Okay. The biggest thing in geometry is you kind of have to have a spatial vision to visualize what we're talking about. And if you struggle with that, you have to be able to put pencil on paper and be able to draw it out. Okay. That's where a lot of students struggle with geometry, is they struggle visualizing. Okay, don't be afraid to write it out and kind of see what would this look like. A lot of the problems that we're going to do today, I will draw them out and just show, hey, here's what it's saying. And when you see it, it makes so much more sense. Okay, don't be afraid to. All right. First thing here, we're going to talk about coordinate. It's delayed. There it is. A coordinate. It's a number used to identify the location of a point. On a number line, one coordinate is used. We usually use x. On a coordinate plane, which we're going to talk a lot about, we use 2 coordinates. Oops, wait. Annotation. There it is. In 2 coordinates system, the coordinate plane, we'll use 2 coordinates, x, y. Okay, and a couple of you asked last week, how do you know which one goes first? I always think alphabet. X comes before y. Then the actual talks about in space. There is such thing as called coordinate space. When you get to Algebra 2, you'll learn about that. But that is the x, y, and z. Okay, that is in coordinate space. But yet again, you still go in alphabetical order. Okay, so x and y, always think about that first. Distance, the absolute value of the difference of the coordinates of the point. Distance is always measured in a positive direction. And think about that in real life here. If you were to go 10 miles north, you travel 10 miles. You go 10 miles east, you still travel 10 miles. 10 miles south, 10 miles. 10 miles west, 10 miles. Anytime we're talking about direction, it's always a positive direction. It doesn't matter if you're going east, west, north, south, right, left, up, down. You're still going to measure direction in a positive answer.
Is it like...
That's the left.
What if you go backwards?
Still positive. We're talking about direction. We're talking about distance. Positive. Length is the distance between the 2 endpoints of a segment. Okay, so talking about the distance between, A and B there. We're going to talk about finding lengths. Congruent segments. 2 segments that have the same length. Try and draw them as best I can here. Okay, congruent segments typically are marked congruent. They'll use tick marks, like something like that, to indicate they are the same or they are congruent. So being able to recognize congruency symbols is going to be important from here on. All right, between. Again, the word between, think about it. You know, if you just think about what's in between, it kind of makes sense here. Given 3 points, A, B, and C, B is between A and C, if and only if all 3 of the points lie on the same line, and AB plus BC equals AC. You'll want to know that kind of right there. That's highlighted for you. But really what that means here is if I have a line, and I have, you know, A, B, and C, well, common sense here is going to tell us this part of the line and that part of the line are going to add up and get us the whole line. Okay, that's all that's saying.
Okay,
if you take 2 parts of the line and add them up, you get the whole line. Again, when you think about the wordy definition, yeah, it's kind of confusing, but look at it, it makes sense. Okay, 2 parts of the line can get us the whole line. A midpoint is the point that divides a segment into 2 congruent segments. So again, if I have a segment here, I'll go A and C again. And right in the middle, if I put the letter M, if that is my midpoint, the left side is congruent to the right side. They are equal. Okay, congruent means they are equal to each other. So they are the exact same. We will do some with midpoints at the end of the lesson here today. Bisect, to divide into 2 congruent parts. If you look at that line, M bisects the line AC there. M bisects it, cuts it up. And then we have what is called a segment bisector, which could be a line, array, or segment that divides a segment into 2 congruent segments. So if I have another line here, we'll go with B and D. And I put a line going right down the middle of it. That is a segment bisector there. I can make it a line bisector if I want to put arrows on it. Okay? And the tick marks again show they are congruent. It's a bisector. Did we already do these? Postulates? We had some other ones. Oh, there's a lot of postulates. 1, 2, 1. The points on a line can be put into one-to-one correspondence with the real numbers. Okay, we're talking about a lot of times number lines and such. We're going to use real numbers. And then 1, 2, 2, that's kind of talking about what that between was talking about earlier, the definition. Where if B is between A and C, then AB plus BC equals AC. And that's that same example earlier. 2 parts of the line will add up and get you the whole line. Okay, that's all that's really saying. And when we look at a problem later, you'll be like, oh, duh, this makes sense. The distance between any 2 points is the length of the segment that connects them. So, for example, there I have a ruler in centimeters. The distance between E and J, so I'm looking from E to J there, is the length of EJ. To find the distance, subtract the numbers corresponding to the points and then take the absolute value. Again, absolute value because distance is always measured in a positive direction. So you take 7 minus 1, you get 6. Absolute value of 6 is 6. If you go the other way even, let's say you want to go 1 minus 7. Well, I still have my absolute value bars there. Absolute value of negative 6 is still 6 as an answer. So either way you look at it, distance, because the absolute value bar will get us a positive direction. So number 1 there. Okay. I have EG. I want to find the distance from E to G. Well, there's E. There's G. My distance, Anna, would be a distance of what?
5.
So 1 to 5, the distance would be, what's 5 minus 1?
4.
What is it? 4 centimeters. That's distance right there. All right. What about the next one now? Let's say EF. Well, now I'm going to go from E to F there. Okay, S kind of between 2 and a 3. Oh, don't worry, the dots will show up there. There they are. So EF, what is my distance from E to F? Troy? 1.5 centimeters. Nice job. And let's go from F to H. Well, I have F and H right there. Still want to find the distance. What would the distance be from F to H? Hannah? Ooh, close. So I have 5.5 right there and 2.5 right there. What's 5.5 minus 2.5? What is it, Austin? 3. Yep, 3 centimeters is correct. All right, try these 3. All right, Johnny, what do you think about number 4? What do you think?
2.
2. Oh, geez, there it is, back again. Annotation on. Yeah, 2, and I said we'll talk about inches. 2 inches, so we're going from C to D. Number 5, find the length of E to C. Okay, so now I'm looking here from E to C. What would my answer there be, Kendrick? Nice job. 5.5 or 5.5 inches. Nice job. And last, number 6. Find the length of B to E. So I'm going that short, small segment right there. Think about it. Yes, ma'am. What do you got for an answer? 1/2 inch is correct. Nice job. All right, next here. Well, now we're going to actually start thinking of our own segments. So number 7 says H is between X and Y. Okay, now again, if you struggle kind of visualizing it, draw it out. So for example, there's XY. Okay. It says H is between them. Okay, so we'll say H is somewhere like right there. HX is 3.9. All right, there we go. 3.9. HY is 6.2. It says to find XY. Well, in order to do that, what do I have to do, Tina?
Don't you have to add the 2?
Add them up.
And then you get like 10.1.
6.2 plus 3.9. I get an answer of 10 point what? 10.1 is our answer. Again, that's what that postulate was saying earlier. That's what that between was saying. I mean, it was kind of looked wordy, but now when you look at it, it's like, well, yeah, that makes sense. The 2 parts are going to add up and get you the whole. Well, what about number 8? I have B is between AC. Same thing here. I'm going to draw my line or my segment there. There's A. There's C. We'll say B is right there. Now it says AC is 14. So my whole length here is 14. BC is 11.4. I need to find AB. Using what I know, what can I do there, Tyler? So I want to find AB. I want to find this distance right there. I know the whole distance is 14, and this partial distance is 11.4. What do I want to do then? Yeah, you want to subtract them. So you want to take the whole minus my part now this time. So 14.0 minus 11.4. Camden, I get an answer of?
Hold on here.
2.6.
I was just writing this down.
2.6 is correct. Nice job. All right, now, the last one down here. Now comes kind of the algebra part into geometry. It might be tough for you to see some in the back there. Sorry. M is between N and O. Yes, sir.
On the last one, like, how do you know
Yeah,
which
two
way?
Because I was given the whole here and a partial, I would subtract it. When I'm given the two partials like this, then you would add them.
Okay.
And a lot of times it just kind of depends what you're looking for. Like this one was asking for the whole line. Well, now I know I'm going to add them. This one was looking for just this little partial one there. So, just kind of drawing it out and seeing what you need would be how you determine that. Good question. Okay. Number 9, though. M is between N and O. It wants us to find NO. Okay, I want to find that right there. Well, it gives me some variables here. What might I want to set up, would you suppose, Max? What do I want to set up here? What's a thing? That's a good point. What do I know that... Okay. What is this 5x plus 2? What does that represent? The whole. So, using our postulates from earlier, 5x plus 2 is going to equal what parts added together? If I take my two small parts and add them together, I get the whole part. So 3x minus 5 plus 17. Here what I get is, I get an equation. Okay, where I have to solve for x. Because again, using that theorem earlier of AB plus BC equals AC. From there I need to solve equations. Anytime I solve equations, I want to get my variables on the what, Peyton? Same side. Okay, so I'm going to subtract 3x. Giving me 2x plus 2 equals 12. Because I can combine negative 5 plus 17 equals 12. From there, it's a two-step equation. What will be next, Drew? Subtract 2. Giving me 2x equals 10. Now I do what here, Jersey?
X equals 5.
Thank you, Johnny. Divided by 2. And I get x equals 5. Jersey, where did I lose you at there, bud?
Just at the beginning of it.
Okay. So if you look here, I had my whole line, which was this right there, 5x plus 2, right? Okay. So the whole is equal to my parts added together. Because if I add those two small parts, I get the whole. So I set those equal to each other so I can solve for x. So I took 5x plus 2, 3x minus 5, and 17. Set them equal to each other and you solve for x. It's using the algebra and geometry part. So from there I got x equals 5. But what do I need to solve for here? What am I trying to find, Max?
NO.
So, trying to find NO here. So I'm going to take this 5, plug it in right down there. 5 times 5 is 25 plus 2 NO equals 27. Or 27 units here. Okay. Try these 3. Gabe, what do you got for answer number 10? Yeah, the answer there is 12. Okay, I'm taking the whole line, which is 25, as opposed to part of my line, which is 13. I subtract them. So I want to find that part right there, and you get 12. Number 11. TV equals 4.5 and VW equals 9.3. And we know T is between V and W. So there's VW. T is somewhere about right there in between. I know the whole length is 9.3. And I know TV is 4.5. Knowing that information, what do I get for an answer, Mr. Boger?
I got 4.8.
4.8, nice job. That'd be another subtraction one. Okay, because you're trying to find the other part of the line. You have to subtract them. Again, visualize, think about what you need to see. 12. E is between D and F. Find DE. Again, I know the whole is 6x. What equation might I set up here? Nick, what do you got for an equation?
6x equals 3x minus 1 plus 13.
Nice job. 6x equals 3x minus 1 plus 13. And again, that comes from the whole equals the sum of the parts. Okay? From there, you solve it. What do you get for an answer of x, Nick?
I don't know.
What do we have to do with our variables? Get them to... So I'm going to subtract 3x. Giving me 3x equals 12. Do you agree? Negative 1 plus 13 is 12? So I get x equals... Now, what's the question asking me for, though? What do I need to find, Jack? I need to find DE. So using that information, I look over here. DE is 3x minus 1. I plug 4 in for x. I get an answer of Jack. 11 is correct. Nice job. Again, using the algebra, we know, plugging that in to work for geometry. Nope. Some of you, maybe. All right. Last one here. Last slide. Now we're going to talk about midpoints. Okay, we're going to talk about midpoints. It says A is the midpoint of BC. Okay, so let's think about it here. I have a line. There's B, there's C. A is my midpoint. So my left side is congruent to my right side, knowing what I know about midpoints here. AB is 5. Using that information, AB is 5. What does AC have to be, Martina?
5? It'd be like the same, right?
It's the same. It's the answer,
Okay,
5.
so what's what
So you have to recognize midpoints means the two sides are going to be the same. There's our answer. Okay, next one, a little bit tougher. Now comes the algebra again. X is the midpoint of YZ. Okay, so here's Y, here's Z. X is my midpoint. XY equals 5x. XZ equals 3x plus 4. I want to find YZ. What do I know about midpoints? It cuts it up into what, Bryce? Half. So what are each sides? They're going to be equal. So what am I going to set 5x equal to in order to solve for x? What'd you say? Nice job. 5x equals 3x plus 4. Again, that's setting up that this side equals that side. So I set up my equation, solve for x now. I need to get my variables on the same side. Subtract 3x on both sides. Giving me 2x equals 4. Divide by 2 and I get x equals 2. Okay. Now, question says I need to find YZ. Well, YZ is this whole distance right there. So I take 2, plug it in there. 5 times 2 is 10. I know my right side has to be what as well? Because they're congruent. My answer is 20. Nice job. Okay. Running out of time here, but you can try.